Hi, this video is about CER report writing. One of the required tasks in Fulton Virtual Physics is to gain proficiency in designing and developing a scientific argument. So the claim, evidence, reasoning report is a structured task in helping you design and develop a scientific argument. So let's go to your syllabus and look at an example of one such a report and see how to write the report. So here is a project titled Scientific Argument. So this is one of the reports that you have to write in here, and I found that a lot of you were quite confused about what is the question of that investigation. So we'll first read this instruction. It says here you will write a claims, evidence, reasoning statement based on your virtual lab simulation you just finished. So that means this report is always going to be based on the lab that you've just finished in this section. So in order to develop your question and your claim, you need to go back to this virtual lab. So let me click on this virtual lab and see what the topic is all about.
You reviewed diffraction.
So this tells me that this lesson question is, how does diffraction occur? Normally, the lesson question or the question for the lab investigation could be your question for the CER report as well. But this question is not really focused, which is why if you use the instructions that are provided in the CER report and go to Ms. Urban's website, it tells you for this lab what the focused question is. Or even if you let it play a little later in the lab, you will notice that there is a much more focused way of writing that question. So let's go back and see how to write the question. So the claim, evidence, justification or reasoning has these 4 parts. So the first thing to do is to identify. You may or may not have a title for this report, but it's good to have one. So diffraction is the title of this investigation. So the question that is quoted in Ms. Urban's website is, how does the angle of diffraction depend on the wavelength of the wave? You can also write this as, how does the wavelength of the wave affect the angle of diffraction? So the question is normally written as investigating the relationship between 2 given variables. So you can always state it in the form of, how does variable A affect variable B? And in this situation, the claim always is going to answer the question. So when you want to write a claim for this, you can say, as the wavelength of the wave increases, the angle of diffraction, and I'm not going to answer this for you, I'm going to leave this blank, and you can say whether the angle of diffraction would also increase or decrease, and if it does either, is there a particular way in which it increases or decreases. So go back to your previous lesson on diffraction, and that should help you consult your notes, and that should help you write the claim correctly. Then for evidence, we have to go and collect data that will help us verify the claim. So that means we want to collect data about how the diffraction angle changes as the wavelength changes. So that means the first thing that I'm going to do is to declare the variables. So what is your independent variable and what is your dependent variable? So the one that you are going to manipulate is your independent variable, and because you want to see as you increase the wavelength what happens to the angle, so wavelength becomes your independent variable and your dependent becomes your angle of diffraction. So that means you have to go back to the simulation and collect data about this. So let's go back to our simulation, which is right here. So I already set the simulation with, you can change the variables. So I set the barrier gap to 3 centimeters. I set the wavelength to 3 centimeters. wave strength to 1.9, and then damping factor 0, and a planar wave. So the only variable that we are going to change is wavelength. The rest all should be controlled, which means they should be maintained constant. And then you run the simulation, and after you run the simulation, you can stop the simulation once the first wave reaches this edge. And you notice that this is the angle at which the wave has spread out or bent from its original path, and the original path being the horizontal left to right. So what you can do is to take a screenshot of this, and then you can go back and copy it into this document as your evidence, which I have it here. So I'm going to just move this into the evidence section. So how do I know the wavelength is 3 centimeters. So how do I measure the angle of diffraction? So I'm going to use shortcut in here, which is, so insert shapes. So I want the angle between this horizontal, darken that line, and also the angle between so this is how much the wave has spread. So if I draw a line at the edge of this will help you determine the angle of diffraction. So you could use a protractor, a physical protractor, and measure this angle out, or you could estimate this angle. I can see that it's a little bit more than 45, so you can estimate this angle. So what you need to do is adjust the wavelength to be different values, and for each wavelength you are going to have to get that snapshot and then measure the angle of diffraction if possible with a protractor. If not, you give a good a rough estimate of that angle. So this is all the evidence. And when you are doing the evidence, you may always want to use data tables. So you can make a table of wavelength versus angle of diffraction. Where possible, you are going to plot graphs. So if you have quite a few values of wavelength versus angle of diffraction, then you can think of plotting a graph. Okay. So this all goes under evidence. Now comes justification or reasoning. So we are going to see how does your evidence prove your claim, and what is the scientific reasoning behind it. Do you have any reason to explain why whatever happened that way? So you want to go back to your science concepts of diffraction and then see if you studied any relationship between the angle of diffraction and the wavelength. If you did, use that equation and mathematically calculate the angle of diffraction. See whether the calculated angle agrees with your measured or estimated angle. If that is so, then that will be your proof that what you expected to happen through your understanding of the concept of diffraction is what actually happened. So under evidence or reasoning, you must use the science concepts in order to establish that your evidence indeed proves your claim. Okay. So that is how you would write a CER report. So again, question, claim, evidence, and justification. The question is always usually available at the beginning of the virtual lab. It must be focused. The claim should answer the question. Evidence means data. So you collect data of the two variables and you put them in data tables, if possible plot graphs. And under justification, think of what science concepts help you understand what you just observed as the evidence. Hope this helps you with writing a CER report. As always, if you have any questions, please do not hesitate to reach me by text or by email. Thank you.